Hi, this is Antje Bart, Technical Marketing Engineer and Developer Advocate at MapBar. In this video, I'll introduce you to Slack After Dark, a fun demo of a Slack-based dating application which showcases an end-to-end containerized and integrated machine learning workflow. Some of the highlights include online model predictions and online model training using Slack as our user interface. You'll also see how a streaming architecture can help you with moving from batch to real-time model training and simplifying your overall model data logistics. For this demo, I've developed two Slack applications. One being the AI Monkey as a backend service, helping us with the daily data ops tasks like testing, training, and deploying our models. And the other one being our customer-facing front-end service called Slack After Dark, the AI-powered dating application. So let's see the two in action. So here's our Slack channel for the demo. And what we will do as a first step is we will provide an image URL and ask our already deployed model to do a prediction. And what the model is trained on is basically to predict whether the person on the image is an engineer or a non-engineer. And this is just a fun way which we will use to run our dating application later on. So we're passing an image. In this case, it's Sheldon Cooper from the Big Bang Theory. And we just take the field of engineer, like a very broad term, so we include the scientists like him. And you can see our AI Monkey application picking up that picture and the task, processing it, and returning the model output, which says this person is probably 36% engineer and a higher probability a non-engineer. So in our case, we want to actually tag Sheldon Cooper as being an engineer/scientist. So our next step would be to provide the human feedback to improve the model. And you can imagine it's not only one person in the Slack channel, but you can have a couple of hundreds or thousands of people helping you to improve your models. So we're running another command here, which is the fix command, passing on the same image, but now we pass on our feedback, which is the term engineer. And then what will happen next is that the AI Monkey will process this command, as we can see now, and it's running a couple of data ops tasks in the background for us. And I will scroll up here a little bit to go through the steps here. So we can see that the AI Monkey picked up our command, it processed it, and as a first step, it actually put all of that feedback into a stream. So this shows how a streaming architecture can be integrated into your model training. So we're providing the live information, saving it to a stream, and then you could have another microservice listening to that stream. And actually, when there's enough information in the stream, enough training data, you would pull that and then retrain the model. And you can also leverage the data platform to store the newly trained model files and version it in the platform, and then deploy it from there. And in our case, I just called the next trained model the V2 model. So you can also see that in the background, the training of the new model is happening, and the image files and the model files get stored and versioned in the underlying file system, and then it gets deployed as another container in our platform. You can also see how the traffic is shifting. So first we just had one model in production, and now with the introduction of the V2 model, we're also shifting the user traffic to that newly deployed model. As a next step, we're running a predict rendezvous command. And this is basically an implementation of the rendezvous architecture where we're querying all of the models in production, but then deciding which value we return to the user. In our case, we want to have the output with the highest confidence score. So if we run the predict rendezvous command right now, you see that I return a couple of different values just for the sake of comparison. So we have an average prediction, and then we also have the max prediction, which is really the model V2 now, which has been trained on the image. And as you can see, it returns a pretty high confidence score that Sheldon Cooper is now 97% engineer, as we provided the training data for it. So this could be used in any version and any implementation you like. As said, you can also implement a low latency response if that's the preferred over the accuracy of the model. And what I'm doing next is actually we want to have some fun with the front-end application. So I'm going to do a login now, and I'm just passing an image of myself to the Slack channel. And you can see that in the background here again, a database is initialized, which basically stores all of the image prediction results. And this is basically how I build up my matching database for the application. And you can also see that here the Slack After Dark Slack application picks up and it runs my picture through that profiling and prediction model, and it comes up with a 64% engineer for myself. It's probably because I'm wearing a Docker shirt on that picture. And we're now trying the match function. And look at that. I got matched to another person from the Silicon Valley show. And it looks like a good match to me. I can live with that. See you, we both have the same kind of humor in wearing those shirts. And this actually concludes my demo. So let's do a quick recap and summary of what we've just seen in the demo. We've seen a live implementation of the so-called rendezvous architecture for online predictions. We've used the Slack UI to pass an image URL and run an image classification for engineer or non-engineer. With the two models in production then, we've run the predict rendezvous command, which sent the request to both deployed models and returned the response we've selected, like prediction result with the highest confidence. To learn more about the rendezvous architecture and its benefits, see the link provided below. You can also use a stream to mirror the traffic to a decoy or canary model and leverage the data persisted there to replay the live traffic for any future use. Next, we've seen how you can implement online model training reading training data off a stream. We've used our Slack UI again to provide feedback on unsure prediction results, which got sent to a stream with another microservice picking up the new training data and then retraining and redeploying another model, with the new model files being stored and versioned in the underlying distributed file system. Finally, we've logged into our Slack After Dark dating application and got matched based by our AI-powered algorithms supported by the underlying database. In this demo, we've used the Mapper data platform for a variety of cases. In case you're new to Mapper, it's a modern data platform which delivers the power of dataware for AI and analytics, effectively handling the diversity of data types, data access, and ecosystem tools needed to manage data as an enterprise resource, regardless of the underlying infrastructure or location. With the Mapper data platform, users can store, manage, process, and analyze all data, including files, tables, and streams from operational, historical, and real-time data sources, all together with mission-critical reliability to meet your production SLAs. In the Slack After Dark demo, we showed how Mapper supports your end-to-end machine learning AI workflows from training, deployment into production, how Mapper can integrate into existing applications, microservices frameworks, and containerization, how Mapper can handle data logistics across files, tables, and streams to support online predictions and online model training. Also, how a rendezvous architecture implementation could look like. And hopefully we showed you that AI and Mapper are a perfect match. If you want to learn more about machine learning logistics and how Mapper can support your machine learning AI projects, have a look at our free ebooks or visit us at mapper.com. Thank you very much for watching.